All right, we're back. Last example for this section. And what we're going to do is we're going to do a one-sided die, a number cube, as well as flipping a coin. And what we're going to do is we're going to create a sample space. We're going to write all the different outcomes and then go through a couple of different probabilities here and rock this out. So it says rolling a one-sided die is going to give us a 1, a 2, a 3, a 4, a 5, and a 6 for the number cube. So if I roll that number cube, these are all the outcomes I could have. And then I could flip a coin. Well, in order to flip a coin, you're either going to end up with a heads or you're going to end up with a tails. And so I could get a 1 and a head, a 2 and a head, 3, 4, 5, and a 6 and a heads on a coin. Or I could get a 1 and a tail, a 2 and a tail, 3 and a tail, 4 and a tail, 5 and 6 in a tail. And so those are all the different outcomes. Well, I've got 6 of them over here and 6 of them over here. So once again, we're going to do favorable over total. And for this particular problem, our total is always going to be 12. All right, we'll take a look. What's the probability of getting tails? There are 1, 2, 3, 4, 5, 6 different ways that we could get tails on here. So all 6 of those would count. These 6 over here don't count. So for this particular problem, we have 6 ways that will work out of all 12 altogether. It's going to reduce down to 1/2, which we know to be 0.5. So that's a probability of getting tails. What's the probability of getting an even number and heads? Well, the only ones that are even numbers and heads are going to be the 2 and the head, the 4, and the 6. So there are only 3 ways that this is going to work out of all 12 together. 3 goes into 12 4 times, so it's going to be 1/4, which you should know to be a quarter. So that's going to be 0.25 will be the answer to that one. And the last one says, what's the probability of getting a prime number? So we're going to consider all the different prime numbers. Our prime number 1 is prime, number 2 is prime, and there's no factors in 1 or 2. There's no factors in 3. Now 4 is 2 times 2, so that doesn't count. We won't use that one. 5 is prime. That one works. Number 6 is 2 times 3. So we're going to use this one, the 2 works. So 1, 2, and 3. And we'll also use 5. So 1, 2, 3. There are 4 of them over here. But it just so happens that there's a 1, a 2, a 3, and a 5 over here with the tails as well. So we'll have 4 outcomes over here that work, 4 outcomes over here that work. And the end result is you'll have 8 outcomes altogether out of the 12 that are total. 4 goes into both of those. 4 goes into 8 twice. 4 goes into 12 3 times. We did this math earlier on a previous video. 2 divided by 3 does give us 0.6 forever, and that would be our probability for that one. So on your quiz, I'll have you come up with a sample space, and you'll just figure out how many outcomes I want, divide them by the total number of outcomes, and then you'll write that percentage in there. It should be pretty simple stuff. There's plenty of notes online. There's plenty of places where you can go through and do your do some extra practice, that kind of thing. You can Google theoretical probabilities, sample spaces, and stuff like that. There's lots of videos. There's this video, obviously, that I'm making for you. And I'll be hanging out on Google Classroom. If you look at the Hangouts, I had a couple people join me just today before I made this video. And, we got to hang out for a little bit. I got to catch up on how things are going with you, what you're up to at home, that kind of thing. So go ahead and check in with me. Let me know that you're healthy, if anything else. And fill in the quick poll assessment for this assignment, but also the quiz assessment for this assignment. I'll be grading those, and I'll let you know how you do on those. All right, you guys are awesome. Stay frosty, and we'll see you around. Go team.